everyone, welcome to another episode on Learn All Things Cyber with T. As I promised that this week we'll be diving into cryptography, cryptanalysis, and the first thing first that I would like to talk about is, when people hear about cryptography, they're like, is it the study of cryptocurrency? No, it's not the study of cryptocurrency. It's a terminology in cyber security. It has to do with securing your data, all of those things around securing your data, encrypting your data, and all of this. So, but first, before we dive into the mathematical part of cryptography, before we talk about all of the codes, how to encrypt and de-encrypt and how it works, how hash works, how SHA-1, SHA-2, MD5. Okay, so before we go into it, it's not like I'm excited about the topic, but I purposely placed the topic after networking because I know these two topics are like topics that people struggle with a lot. I also struggle with it because of all of these public key infrastructure and all the rest. But before we dive into it, this first week, I would use it to explain the terminologies. What does each terminology mean? And explaining it in simple terms so that by the time we dive into the other part of it, you already have an idea how this works. Let's go into what is cryptography. So cryptography is like a secret writing that only the person you have written it to and yourself can read it. That's what cryptography in simple terms means that you have written something and sealed it up, or maybe you have written something, placed it in a box, locked it up, and only the person with the same key or a similar key or the same combination of keys can actually open and then read what is inside. So if somebody steals that box, it's very useless to them because they will not be able to see exactly what is in the key. And so usually it's like, say, a message that is turned into an unreadable code. So if somebody tries to steal it, they wouldn't understand it. Only the person with the right key would be able to turn it back into normal text. So we have different, terminologies around this. We have something called plain text. It's an English word. You know what plain text means? Plain text is just a text, like my name. And everybody can read my name because it's in plain language. So we have cipher text. So usually cipher text is when we have this plain text converted into cipher. Cipher is like some codes that you will not be able to read, and then it's only the person with the right key that converts it back to plain text and will be able to read it. Like I said, cipher are kind of set of codes. What is cryptanalysis? So cryptanalysis is like, say, the ways to break some of these secure secure mechanism, like cryptography is securing, and then the way to break into this security is what cryptanalysis talks about. So stay tuned, I'll be right back. So like I said, cipher is a kind of code or algorithm that you can use to create a cipher text that no one will be able to read except they have the right key to de-encrypt what you have written. So I have this very simple example that would help you to understand. I know you have watched so many movies where they are using different ciphers to send a message, but there is this simple cipher called scissor cipher. So say for example, we want to actually encrypt hello, Hello. If we want to encrypt it with scissor cipher, it's a very simple cipher, and we want to encrypt it, we just need to shift 3 alphabets. And if you shift hello, for the H you get a K, for the E you get an H or a H, or for the L you get O, and then the second L you get an O, and then for the O you get an R. And how does this work? H-I-J-K, E-F-G-H, pick the H, L-M-N-O, O is like the third. And then, the same for the L. And when you want to de-encrypt it, you just shift back the alphabet 3 times. And this is how plain text and cipher works. When it comes to scissor cipher, there are so many ciphers out there. So let's leave that part and then go into this diagram that I have on the screen. We have cryptology. Cryptology is like a study combination of cryptography and cryptanalysis. Like I told you, cryptography is like securing, your information, and then all of the encryption and decryption. And then cryptanalysis, wanting to break that system that secures, all of your encryption and decryption. Just wanting to break it. That's what cryptanalysis does. And then in cryptography, we have like 3 types of cryptography. We have the symmetric, ciphers, we have the asymmetric cipher, and we have the hash function. And then for the symmetric, we have something called the block cipher. So for symmetric, we have block cipher, we have stream cipher. So now, what is generally the difference between all of these, different, ciphers that we have? So let's keep our focus on symmetric, and I will still dive deep into symmetric encryption or cipher or whatever it is. I'll still dive deep into it, but just wanted to give you a high level overview of what they mean. So for block cipher, it's like saying you have a box of message. You just put your message inside of it, you lock it up, and then you send it. But for stream is like saying for every word you say, like a walkie-talkie, when people say, something over, something over. So stream is like every word you send, you encrypt it. So it's like a streaming, like you're streaming and encrypting. Unlike for block cipher that there is a kind of, bits attached to it. You keep the message into it. Even if the data is not up to the bits, there is a padding before you send out the message. But on the other side, streaming is quite different. For block, you usually use block for files and the rest. But streaming, you usually use to stream for voice over IP and all of those. So that's about it when it comes to block and stream cipher. And like I said, we have different type of cryptographic algorithm, which is attached to what I just explained initially. There is hashing algorithm, there is symmetric encryption cipher, we have asymmetric encryption cipher, we have key exchange, we have digital signature algorithm. And I'll be explaining them one after the other. So for hashing algorithm, it is used to check the integrity, that a data is not changed. We usually use this for checksum, and I'll explain what checksum mean later in the lessons. But we have different algorithm attached to hashing, and we have something called message digest 5, MD5. We have the SHA. So we have SHA. SHA is the earliest form of SHA is like SHA-1, which is not used anymore. Really, we have SHA-2, and this is where we have the SHA-256. I'll be explaining all of this in details as we go further in the lecture. I just want you to have an idea that something like this exists. For MD5, one of the reasons why people are very skeptical about MD5 is because it's not very secured. There is a tendency to have hashing collision when it comes to MD5, and I'll be explaining further in the lecture also what hashing collision also means. Further in this lecture, what hashing collision means. For symmetric encryption, this is an encryption where we have a single key. So there's only a single key that is being shared from the sender to the receiver. Now we're explaining this further, don't worry. The next lesson, I'll be doing it on the board, so I'll be explaining in plain text what it means for a sender and a receiver to first share the secret key with one another, and then they use this key both to encrypt the data, and then the receiver uses the same key to de-encrypt the data. Now for asymmetric, it's the opposite of symmetric. And for symmetric is very fast because it uses just one key. But for asymmetric, there's 2 keys involved. There's a private and a public, and then the sender is sending with 1 key. The receiver is trying to de-encrypt with the sender's public key. So the sender is encrypting the data with their private key, sending it to the receiver, and the receiver is de-encrypting with the sender's public key. I'll be explaining this in detail, and we have also what we call the key exchange algorithm. We have also what we call the digital signature algorithm. And so basically, I can give you kind of a high level overview of what all of these simply mean before we dive into the attack part of cryptography. Stay tuned. So let me give a little bit of context to what I was explaining initially about symmetric key, symmetric encryption. We call it symmetric key sometimes. Symmetric hashing algorithm, symmetric encryption cipher, asymmetric encryption cipher. They are type of cryptographic algorithm, and then key exchange algorithm and digital signature algorithm. So I'll put a little bit of context to it. I was trying to explain it in a rush initially. So like I said, for symmetric key algorithm or encryption algorithm, usually there is a single key both for encryption and decryption. So say for example, I'm trying to send a data to say Bolanle. So we have just one key between me and Bolanle. Now, why symmetric is not like the best to use is because we still have to find a way to exchange this key between ourselves. And if we are sending this key not in a very secure way, then it's not the best, because both of us need the same key. We have to, send those keys to each other to be able to encrypt from my end, and then she would decrypt the message from my end. So, but it's very fast. It's very fast for large amount of data because you're just using one key. So it's very fast. An example of symmetric key algorithm would be advanced encryption standard. We have data encryption standard. We have something called Blowfish. Blowfish is also an example of symmetric algorithm. Now for asymmetric, because I was explaining in a rush, now I'll explain properly. So you use the cryptographic algorithm to generate a pair of key. A pair means two things: public and private, between a receiver and a sender. I'm just saying, like, let's say I'm a sender now. I generate a pair of key, which contains both the public and the private. Now, what it means is that I can use the public sender to encrypt the message. Now, the only person who can de-encrypt that message is if they have the private key pair to that, to what we have created using the cryptographic algorithm. Say for example, I have the private public key to be AB and the private key is CD. The only person that can open the message that I've encrypted with AB, which is the public key, is if the receiver, the recipient, have the CD as the private pair to that public key that I've used to lock it up. I hope this explains it a little better. It is more secured for key exchange, but it's slower. So it is more secured because I don't have to share anything with the person. The person would have that pair with them. I would have the public pair, which is visible, right? I can use it to encrypt the data and then send to them. The private is only known to them. So it's only the private that they can use to now de-encrypt that cipher text, like I told you what a cipher text is, to a plain text, and they'll be able to read the message. And some of the example we have, elliptic curve cryptography is part of asymmetric cryptography. And again, I mentioned something about hashing. So hashing is converting like a data into a fixed length hash, and it is a one-way function. It cannot be reversed. Like if you have an hash, you cannot really, reverse it. There is an hash, there is a word for each hash. So it cannot be reversed. And it's also used to verify integrity. It can be used for password storage. If you'd like to save your password, say for example, for some of you that uses something like LastPass, password manager. So usually they don't keep the password in plain text. They convert it to hash and then store it. And it's very difficult for you to, turn it back into the password. Now, they also use it for file checksum. So for example, there is an evidence that I've kept to be sure, because, evidence is being handled by different people. So to be sure that, the evidence has not been tampered with, they check the checksum just to be sure that the evidence, the last person that dealt with the evidence was still intact before the next person takes it up. And like I mentioned, that there are different examples of a machine algorithm. We have the SHA-1 that nobody uses right now. We have the MD5 that is very associated with hashing collision. And what is hashing collision? Hashing collision just means that two words having the same hash. It's very rare, but it's very possible, and it's very associated with MD5, which is message digest. SHA is secure hash algorithm. Now, hashing collision, like I mentioned, it shouldn't happen It is, if it happens, then attackers can exploit this type of a vulnerability if you have the same word or the same file having the same hash, having the exact same hash. So we also have SHA-2, which example we have SHA-256, SHA-512. Now we also have something called key exchange algorithm. So it's like sharing a key securely over an untrusted network. Initially I was mentioning something about symmetric, encryption cipher, how that, encryption algorithm, you need to share the same key. So how then do you share this key in a very secured way? And one of the example is Diffie-Hellman. It is a type of key exchange algorithm. And how does this algorithm really work in a real life situation? Say for example, person A and person B, they want to create like a color, a common color that they don't want any other person to know about. Like they're in a public space. They are trying to paint their room and they want a color. Say for example, you have a public color as yellow. Everybody knows this yellow. It's very obvious to everybody. Then they have secret colors. So let's say person A have a secret color red, person B have a secret color blue, and then they try to take the color, mix it up with their secret color and exchange it, send it to one another. So person A would then have blue and yellow, person B will have red and yellow, because red belongs to person A and then blue belongs to person B. And once they have this exchange, they mix it again with their secret color. So person A with blue and yellow will mix it again with red. Person B with blue and yellow, with red and yellow would mix it again with blue. And then a final color, which is the final shared secret color, that is the cryptographic key that they need for key exchange. So even if you are watching what they are doing, because you don't know what their secret colors are, you would never be able to tell what the ingredient is. And then this is what we have as key exchange algorithm. And for digital signature algorithm, is just about signing your own message so that you can authenticate yourself to the recipients. Say for example, I taught you about authentication before, authenticating that you are who you are to the system. And then digital signature can also be used for non-repudiation. So non-repudiation is a process where no one can deny they have actually carried out a process because it's recorded in the system. So you can't really say, I didn't do it, when it's your signature exactly on it, or your name or your ID, whatever it is. And the other part that we also can use digital signature for would be integrity, to be sure that the message is not modified along the way. So after all of this explanation, we would quickly move into some of the cryptographic attacks that we have. We have different cryptographic attack, and we'll quickly move to one of them. And the first one will be brute force. I know many of us are very familiar with brute force attack. So brute force is like guessing every combination possible. So you're just guessing a combination of letter, numbers and special character. It takes long. Brute force takes long because it's like you're walking without direction, trying to guess a cryptography, maybe cipher or a password or whatever it is. It's a very long situation. Now for dictionary attack, we have this attack where we have a list. Is like you have a dictionary that is full of common password, common pin, common words, common phrases. So this is also an attack that can happen with cryptography, where people are trying to guess what it could be, or attacker is coming up with different combination that could result in the words they are looking for or the key they are looking for. And also for birthday attack. So birthday attack is usually based on birthday paradox. So it's like saying when you have a combination of 23 people, there's a tendency, 50% probability that 2 people in that group will have the same birthday. So now for birthday, when it comes to an attacker, it's like saying that instead of them, trying to crack the system, doing cryptanalysis, they are trying to look to see if they produce 2 random inputs that would have the same hash. So it's the same like hash collision. Now also there's something called downgrade attack, and this attack could happen when the attacker is convincing you or convincing the system, whatever it is, to go into a lesser algorithm that is easy to crack. So say for example, maybe the system is using something like SHA-2, SHA-256, and then the attacker is convincing the system to use a lesser version, so a version that is less secured, so that they'll be able to break into it. Say use something like MD5 so that they can easily break into it. Also, there's something called side channel attack, and this attack is, how do I explain it? So instead of cracking the system, they are looking at behavior or physical behavior or behavioral pattern. Say I want to withdraw from my ATM, for example. So instead of wanting to crack the ATM, they are looking at how you're pressing the numbers with your fingers. They are monitoring it. Or say, for example, I can use another example. So when a server is processing a 1, it uses more power than when it's processing a 0. So an attacker can also study the power use to be able to decide, what the key are, bit by bit kind of way. So those are like the attack. And I think this is all I have for this week. Stay tuned for next week. We're going into a few mathematical concepts or few processes to show how symmetric, asymmetric in simple terms. I'll be using the board to explain all of this. See you next time. Bye.